branch circuit wiring should not be run through one dwelling to feed another dwelling. This practice violates the National Electrical Code, also known as the NEC. The NEC is a comprehensive set of standards and regulations governing the safe installation and use of electrical equipment. Adhering to the NEC is essential for protecting both people and property from electrical hazards. Specifically, the NEC prohibits service conductors from running through one dwelling unit to supply another. This means you cannot route electrical wires, such as this for an air conditioner, through a neighboring unit to reach an external location. There are two primary reasons for this restriction. Firstly, it poses a significant safety hazard. In the event of a fire within a neighboring dwelling, the electrical wires passing through the unit could be compromised, potentially initiating a fire in the unit being served. Secondly, it constitutes a direct violation of the NEC. The NEC holds the force of law, and compliance is mandatory. To route electrical wires through another dwelling, you must obtain explicit permission from the property owner of the dwelling and secure the necessary permits from the local building department. The underlying principle is that each dwelling unit should have its own independent electrical system, ensuring both safety and proper control. When dealing with electrical installations in multi-dwelling units, it's crucial to understand the specific requirements for branch circuits. Branch circuits are the wiring that extends from the final overcurrent protection device, such as a circuit breaker, to the outlets, lights, and other electrical loads within a dwelling unit. The NEC provides detailed guidelines on how branch circuits should be installed, protected, and used to prevent hazards. Firstly, each dwelling unit must have its own dedicated branch circuits. These circuits should not pass through or supply power to any other dwelling unit. This ensures that each unit has its own electrical system and that a problem in one unit will not affect the others. Secondly, branch circuits must be properly sized and protected. The size of the wire used for a branch circuit must be large enough to carry the load that it will be supplying. The circuit must also be protected by an overcurrent protection device, such as a circuit breaker, that will trip if the circuit is overloaded. Thirdly, branch circuits must be installed in a safe manner. Wires must be properly insulated and protected from physical damage. Outlets and switches must be properly grounded to prevent electric shock. The NEC also specifies the types of wiring methods that are allowed for branch circuits in multi-dwelling units. Common wiring methods include non-metallic sheath cable, also known as Romex, and rigid metal conduit. Each wiring method has its own advantages and disadvantages, and the choice of wiring method will depend on the specific application. When installing branch circuits in multi-dwelling units, it's important to follow all of the requirements of the NEC. This will help to ensure that the electrical system is safe and reliable. In addition to the NEC requirements, there may also be local building codes that apply to electrical installations in multi-dwelling units. These codes may be more restrictive than the NEC, and it's important to be aware of them before starting any electrical work. For example, some local codes may require that all wiring in multi-dwelling units be installed in conduit. This is a more expensive wiring method than using non-metallic sheath cable, but it provides better protection against fire and physical damage. When planning an electrical installation in a multi-dwelling unit, it's always a good idea to consult with a qualified electrician. An electrician can help you to determine the best wiring methods for your application and ensure that all of the work is done in accordance with the NEC and local building codes. The NEC addresses specific concerns regarding the installation of electrical systems in multi-dwelling buildings. It is important to be aware of these regulations to ensure safety and compliance. Firstly, the NEC mandates that each dwelling unit must have its own separate electrical service. This means that each unit must have its own meter and service panel. This prevents one unit from being able to control the power to another unit and also makes it easier to track energy consumption. Secondly, the NEC requires that all wiring in multi-dwelling buildings be installed in conduit or other approved raceway. This helps to protect the wiring from damage and also prevents the spread of fire. Thirdly, the NEC specifies the number and type of receptacles that are required in each dwelling unit. This ensures that there are enough outlets to meet the needs of the occupants and that the outlets are properly grounded. Fourthly, the NEC requires that all multi-dwelling buildings have a fire alarm system. This system must be designed to alert occupants to a fire and to provide them with enough time to evacuate the building. Fifthly, the NEC requires that all multi-dwelling buildings have emergency lighting. This lighting must be designed to provide enough light for occupants to evacuate the building safely in the event of a power outage. Sixthly, the NEC requires that all multi-dwelling buildings have a standby power system. This system must be designed to provide power to essential equipment, such as fire pumps and elevators, in the event of a power outage. In addition to these specific requirements, the NEC also contains general requirements for electrical installations. These requirements apply to all types of buildings, including multi-dwelling buildings. It is important to be aware of these requirements to ensure that all electrical work is done safely and in compliance with the code. The National Electrical Code Article 225 covers outside branch circuits and feeders. The scope of Article 225 includes requirements for outside electrical wiring on buildings and structures, and also the wiring between buildings and structures on the same premises. Part Roman 2 of Article 225 focuses on circuit exits and entrances for buildings. Section 225.30 outlines the number of supplies allowed on a single building or structure. Generally, a building or structure can only be supplied by one feeder or branch circuit unless specific conditions are met as described in 225.33. These exceptions include fire pumps, emergency systems, legally required standby systems, optional standby systems, and parallel power production systems. Section 225.31 specifies that overhead spans of open conductors must have a minimum clearance of 10 feet above finished grade, sidewalks, or any platform or projection from which they might be reached. Section 225.32 addresses attachment points, stating that they must provide minimum clearances as outlined in 225.31. Article 230 of the NEC pertains to services, which are the conductors and equipment used to deliver electricity from the serving utility to the premises wiring system. This article covers various aspects of service installations, including overhead and underground services, service equipment, and grounding requirements. Article 230 is crucial for ensuring the safe and reliable delivery of electrical power to buildings and structures. Some of the key sections include 230.6, which discusses underground service conductors, 230.7, which addresses other conductors considered outside the building, and 230.8, which mentions raceways to drain. Section 230.24 covers clearances from ground for service conductors and cables. For example, conductors must have a clearance of not less than 3 feet from windows, doors, porches, fire escapes, or similar locations. Over residential property and driveways, service conductors must have a clearance of not less than 10 feet. Over public streets, alleys, roads, and parking areas subject to truck traffic, the clearance must be not less than 18 feet. The height requirements for service conductors are critical for ensuring safety and preventing accidental contact. Section 230.42 covers minimum size and rating for service conductors, ensuring they are adequately sized to handle the electrical load. Section 230.70 addresses the location of the service disconnecting means, which must be readily accessible and located either inside or outside the building at a readily accessible location nearest the point of entrance of the service conductors. The purpose of this is to allow for quick and easy disconnection of power in case of emergencies. Section 230.85 discusses emergency disconnects, stating that for 1 and 2 family dwellings, an emergency disconnect must be installed at a readily accessible outdoor location. These disconnects provide a means to quickly energize the entire dwelling in case of an emergency, such as a fire. Section 250 addresses grounding and bonding, which are essential for electrical safety. Grounding connects electrical systems to the earth, providing a low impedance path for fault currents to flow back to the source. Bonding connects metallic parts of the electrical system together to ensure that they are at the same electrical potential. Proper grounding and bonding help to prevent electric shock and minimize the risk of fire. The NEC grounding requirements are detailed and complex, covering various aspects of grounding electrode systems, equipment grounding conductors, and bonding jumpers. Some key sections include 250.24, which addresses grounding separately derived alternating current systems. Section 250.30 covers grounding requirements for separately derived alternating current systems. Section 250.50 pertains to grounding electrode systems. Section 250.66 addresses the size of the grounding electrode conductor. Section 250.104 outlines the bonding of metal water piping systems and other metal systems. Section 250.118 specifies types of equipment grounding conductors. These grounding and bonding requirements ensure a safe and reliable electrical system. The NEC Table 310.16 provides ampacity ratings for conductors. Ampacity refers to the maximum current, in amps, that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. This table lists ampacities for various conductor sizes, insulation types, and ambient temperatures. It is essential to select conductors with adequate ampacity to prevent overheating and potential fire hazards. The ampacity ratings in Table 310.16 are based on specific conditions such as the number of conductors in a raceway or cable, the ambient temperature, and the conductor's insulation type. Correction factors are applied to adjust the ampacity for conditions that differ from the base conditions in the table. For example, if the ambient temperature is higher than the temperature listed in the table, a correction factor must be applied to reduce the ampacity of the conductor. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, adjustment factors must be applied to reduce the ampacity of the conductors. Table 310.15b3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. These adjustment factors are based on the percentage of ampacity reduction required for different numbers of conductors. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the ampacity of each conductor must be reduced by 80%. If there are 7 to 9 current-carrying conductors, the ampacity must be reduced by 70%. It's crucial to apply these adjustment factors correctly to ensure that conductors are not overloaded. Article 314 of the NEC covers outlet boxes, conduit bodies, and handhole enclosures. These enclosures are used to protect electrical wiring and to provide a safe and convenient way to make connections. Article 314 specifies the types of boxes and enclosures that are permitted for different applications, as well as the requirements for their installation. For example, outlet boxes must be securely fastened to a structural member, and they must be sized appropriately for the number of conductors and devices they contain. Conduit bodies must be installed so that they are accessible for maintenance and repair, and they must be properly grounded. Handhole enclosures must be located in a place where they are not subject to physical damage, and they must be equipped with a cover that is securely fastened. Article 334 of the NEC covers non-metallic sheathed cable, also known as Romex. This type of cable is commonly used for residential wiring, and it consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Article 334 specifies the types of non-metallic sheathed cable that are permitted for different applications, as well as the requirements for its installation. For example, non-metallic sheathed cable must be supported and secured at intervals not exceeding 4.5 feet, and it must be protected from physical damage. It cannot be used in wet or damp locations unless it is specifically listed for that purpose. It also cannot be used in exposed applications where it is subject to physical damage. Article 344 of the NEC covers rigid metal conduit. This type of conduit is made of steel or aluminum, and it provides excellent protection for electrical wiring. Article 344 specifies the types of rigid metal conduit that are permitted for different applications, as well as the requirements for its installation. For example, rigid metal conduit must be supported and secured at intervals not exceeding 10 feet, and it must be properly grounded. It can be used in wet or damp locations, and it can also be used in exposed applications where it is subject to physical damage. Article 400 of the NEC covers flexible cords and cables. These cords and cables are used to connect portable appliances and equipment to the electrical system. Article 400 specifies the types of flexible cords and cables that are permitted for different applications, as well as the requirements for their use. For example, flexible cords and cables must be suitable for the voltage and current they will carry, and they must be protected from physical damage. They cannot be used as a substitute for the fixed wiring of a building, and they cannot be run through walls, ceilings, or floors.